Welcome to the AI Checkpoints. So today we're diving into something really fundamental for AI agents, especially the ones interacting with the web. It's all about memory, or maybe the lack of it. But first, just our standard reminder. This content, the discussion you're hearing, it's generated by AI. All right, our mission today is to really unpack this paper, ReSum, Unlocking Long Horizon Search Intelligence via Context Summarization. It's from researchers at Tangi Lab Alibaba Group. We want to understand how they're tackling this huge problem, the memory wall, that stops LLM agents from doing really complex, long searches. They're claiming indefinite exploration. Let's see how.
Yeah, indefinite exploration is a bold claim, but it gets right at the heart of the issue. These LLM-based agents, particularly web agents, are pretty good now, often using the React paradigm.
Right, the thought, action, observation cycle. It works well for simpler tasks.
Exactly. Lets them handle knowledge-heavy stuff, but React has this built-in limitation.
The context window limit. We keep bumping up against this. It's like the agent has a notebook, and for every thought it has, every click it makes, every web page snippet it reads, it writes it down.
A very diligent note-taker.
Too diligent, maybe, because eventually that notebook just gets full, especially for the tough queries.
Precisely.
Yeah.
We're not talking about finding a single fact. We're talking about queries with multiple people, events, maybe uncertain information, things that need digging.
Yeah, lots of steps.
And the history just grows and grows. The paper actually gives some hard data on this. They looked at their WebSailor 7B agent
Okay.
on the Browse Comp and benchmark.
Yeah.
Most of the time, when it succeeded, it finished in under 10 tool calls. Pretty quick.
But the failures.
The failures. They consistently went over 10 calls, often hitting 20 or more, and that pushes them right past the typical 32,000 token limit.
So the agent literally runs out of memory mid-task. It forgets what it found earlier, gets stuck, and just stops. Premature termination, they call it.
Exactly. It can't hold the entire reasoning chain in its head, or rather in its context.
And that example query they used really drives it home, the one about the painter. His father died of heart disease, he had a sister, 5 kids, marriage broke down, 3 more relationships, then asking for the literary work based on him.
Yeah, that's not a quick Google search. That needs multiple search steps, synthesis, maybe backtracking. React just wasn't built for that kind of marathon.
Okay, problem clearly defined. The notebook gets full. So what's the fix? This is where ReSum comes in.
Right. ReSum is their novel approach, designed specifically to break this barrier and enable, well, that indefinite exploration.
How does it work? Is it just a bigger notebook?
Not quite. It's more about smarter note-taking. Instead
Yeah.
of just endlessly appending the history like React, ReSum periodically calls a special summary tool,
Okay, summarizer.
but a very specific kind. It takes that long, messy history, all the thoughts, actions, observations, and distills it down. It creates a compact reasoning state. Think of it as a structured summary.
Yeah, so like an executive summary of the investigation so far.
Exactly. It captures the key findings, the verified evidence, crucially, what's still missing. And then here's the key part. The agent's working history is reset.
Reset, so it wipes the old notes.
It wipes the detailed old notes, but it starts the new segment with that compact summary, so it knows everything important discovered before, but without the massive token overhead.
Okay, so it throws out the rough drafts, but keeps the polished summary to continue working from. That avoids hitting the context limit.
Precisely. It can keep exploring, building on prior knowledge, without that memory constraint looming.
Now, you mentioned the summary is special. Did they consider just, like, chopping off the oldest history?
They did. They tested a baseline called recent history, which basically just kept the last, say, 22,000 tokens.
And how did that work?
Not well. It turns out just blindly truncating often cuts out crucial, goal-relevant information found early on. You lose continuity. ReSum was much better because the summarization is intelligent.
Right, you said it identifies gaps and next steps, so this isn't just, summarize this text.
Absolutely not. It's goal-oriented summarization. The tool needs to sift through potentially noisy web data, pull out verifiable facts, pinpoint what information is still needed to answer the main query, and even suggest where to look next. It's doing some reasoning itself.
That sounds computationally intensive, too. Does the summarizer need to be a huge model?
That's the interesting part. They developed a specialized tool, the ReSum Tool 30B. It's based on a 30 billion parameter model, fine-tuned specifically for this task.
Okay, 30 billion is decent, but not enormous by today's standards.
Right. And here's the kicker. This specialized 30B model consistently did a better job at creating useful summaries for the agent than much larger off-the-shelf model.
Really? Better than, say, a 200 billion parameter general model.
Yes. The paper shows results where ReSum Tool 30B used for summarization led to better overall agent performance than using giants like Qwen 3235B or DeepSeek R1671B for the same summary step.
Wow. So specialization really matters here. A fine-tuned expert beats a generalist giant.
It's a strong demonstration of that principle, and the impact was immediate. Just adding the ReSum paradigm, using this tool without any extra training on the main agent,
Mm-hmm.
gave an average performance boost of 4.5% across different agents and benchmarks like GIIA and BrowseComp. That's a significant jump, training free.
Okay, 4.5% just by managing memory better is impressive. But there's another piece, isn't there? The agent itself needs to learn how to use these summaries effectively.
Exactly. You've changed the input. Instead of a long stream of history, the agent now gets these compact summary states periodically. It needs to learn how to reason from that.
Which requires training.
Right. And that's where ReSum-GRPO comes in. It's a tailored reinforcement learning approach they developed.
GRPO, what's the core idea there?
The key innovation is something they call trajectory segmentation. Remember how the summary tool naturally breaks the long task into segments?
Yeah, each time you summarize, you start a new segment based on that summary.
GRPO leverages that. Instead of trying to assign rewards to every tiny action within a segment, which is super hard and noisy, they use a simple overall reward for the entire trajectory.
So did the agent get the final answer right? Yes or no?
Basically, yes. A 1 for correct, 0 for incorrect. And then this is the clever part. They broadcast the success or failure signal back to all the segments within that trajectory.
Ah, I see. So if the agent succeeds in the end, every segment, including the summary creation steps within them, gets a positive reinforcement signal.
Exactly. It encourages two things at once. First, it teaches the agent how to effectively use the summary it's given to guide the next steps. Second, it teaches the agent to perform actions within a segment that will lead to a good, useful summary later on.
It connects the quality of the memory management directly to the final task success.
Precisely. It learns to gather information for the summary and learns to use the summary.
And did this training work? What were the results?
Oh, this is where the big leap happens. After training with ReSum-GRPO, even with just 1,000 training samples,
Only 1,000? That's tiny for RL.
it's incredibly efficient. Their WebSailor 30B agent, after this training, achieved a 33.3% success rate on BrowseComp.
Okay, 33.3%. How does that compare?
It blows past existing powerful agents trained on much more data. For example, USearcher 32B got 15.6%, MiroThink of 32B got 17.0%, and those were often trained with 10,000 or more samples.
So more than double the performance with maybe 1/10 of the training data.
Yeah, it really highlights how fixing the fundamental memory bottleneck enables much more effective learning. The training wasn't fighting against the agent constantly forgetting things.
Let's make this concrete. Can we walk through that flea example they mentioned, how ReSum actually solves it?
Sure, it's a great case study from BrowseComp. The query is about comparing the maximum jump distance of two flea species, Cetenocephalides canis and Cetenocephalides felis felis, based on a specific study.
Okay, seems simple enough, but probably requires finding specific numbers from a paper or article.
All right, so the agent starts searching. In the first segment, it does pretty well. It identifies both species correctly and finds one of the key values, 15.5 centimeters for C. felis felis.
Good start, but it needs the other value.
Exactly. But as it keeps searching for the C. canis value, looking through results, maybe getting sidetracked by other details in the study, its context window fills up.
Hit the wall. If this was just React,
It would likely fail. It might forget the 15.5 centimeter value it already found, or forget which species it was still looking for, and just terminate or loop inefficiently.
okay, but with ReSum.
ReSum triggers the summary tool. The tool processes the history and generates that compact state. Crucially, the summary explicitly notes, found 15.5 centimeters for C. felis felis. Still need value for C. canis.
Ah, so it highlights the gap.
Precisely. The agent then restarts its reasoning, but now its input is that focused summary. It knows exactly what piece of information is missing.
So its next action is probably much more targeted.
Absolutely. Its next search query is likely something very specific, like Cetenocephalides canis maximum jump distance study details from summary, and boom, it finds the missing value.
Yeah.
13.2 centimeters.
And then it can put it all together.
It might take another segment or two to verify context, make sure the numbers are comparable from the study, and then formulate the final correct answer. But the key was that the summary allowed it to bridge the gap caused by the context limit, turning one long, memory-intensive task into manageable subproblems.
That makes perfect sense. The compression was essential to maintain focus and eventually succeed.
So when you put it all together, ReSum really seems like an elegant solution. It doesn't require massive architectural changes to the LLM itself. It adds this smart memory management layer on top.
Tackling the memory wall, which feels like a fundamental blocker for more complex autonomous agent behavior.
Definitely. And they're already thinking ahead. Right now, the summary tool is triggered by a simple rule like when the context buffer is nearly full. The next step they mention is making this trigger intelligent, allowing the agent itself to decide when it needs to pause, reflect, and summarize its findings.
Like metacognition for the agent. It learns when its own working memory is getting cluttered and decides to clean house.
Exactly. True autonomous context management. That feels like the next frontier.
What really strikes me is the efficiency gain from the ReSum-GRPO training, doubling performance with so few samples just because the underlying memory issue was addressed.
It does make you wonder, doesn't it? If solving these architectural bottlenecks first makes subsequent learning so much more efficient, maybe we can train highly capable agents much faster than we thought. Perhaps the era of needing massive data sets for every single task is, well, maybe starting to shift.
Something for us all to think about as these agents get more sophisticated. Fascinating stuff. Hit like and subscribe if you like the content. See you next time.